So, okay, very good evening to all. Today is the third day of the manual design for RC elements. Today we'll discuss about the some parts about the columns. Okay, today we'll discuss about the columns. What are the things to need the design for your column designs? Okay, so first of all, I tell about some positioning of the columns. Positioning, positioning or fixing of columns. Okay, fixing of columns in your building. The first step is the fixing of columns in your building. This is the first step. You create any plan. Okay, first of all, you create the any plan. Sorry. First of all, you create the any plan. The column fixing is the important one. Okay. The column fixing is the important one for your building. The first condition is the column fixing. I tell about one by one how to fix your columns. Okay. The first condition is the first condition you go for near the corner of the building. The every building you provided the column compulsory for these corners. Okay. All the corners you will be provided the compulsory for this column. This is the column. I provide the four columns for this corner. Compulsory. You provide the all the corners. This is the symmetrical. You go for unsymmetrical or anyone compulsory. The first step is provide the compulsory. You provide the corner columns. Okay. Compulsory. You will be provided the corner column. This is the first step. Your building is your plan is there. You provide the any corner. You will be compulsory. You provided the column for your buildings. Okay. Next step. The next step is a intersection of the wall. Avoid the projection of column outside. The third one is a avoid the column projection. Next second point is a intersection of the beam columns. They provide the any intersection. This is our plan. The beams will be intersection. So I provide this area for this column. This is a intersection of the beam column point. Okay. This is a beam by wall. Any place the beam or wall will be intersect, that place we will be provide this column. This is our beam will becomes this area, the beam will become. So I provided the column for this area. Otherwise, you go for secondary beam, the column will be not needed. But otherwise, sometimes you go for this is our beam, this is our beam, three beams are joining in this place. Compulsory, you provide this column. This is the second point. You provided the joining of the beams or walls compulsory. Will provided the columns. The first point is a corner is a compulsory. Second one is the joining area will be compulsory. You provided the columns. The next point, depth of the column contained with the major axis. This is the main point for your column. Depth of the column with contained with major axis. Okay. Depth of the column contained with the major axis. The first of all, this is our column cross section. Okay. This is the column cross section. Assume as a column cross section. This is our width. This is our depth. Okay. This is our column depth. This is our column width. This is a two area column width and depth. The inertia force. The inertia force is higher in depth side. Okay. This is the inertia force. The inertia force is higher in depth side. So your orientation you provide in this pen. I provided this simple example. This is our plans. Okay, this is our plan, simple plan. I take this one beam. This is a longer beam. This joining as a one shorter beams. Okay, I measure this dimension. This is a 3 meter beam. This is a 5 meter beam. So, okay, this is a 3 meter beam. This is a 5 meter beam. I provided the one column. I provided the one column. Depth of the x, the depth of the column will be orientation to longer beam set. That is the main point. See this. This is the depth area. The depth area is oriented into longer beam set. That is the main point. Okay. That is the main point. I go for another example. I take this another one example. Says automatically I take this. One second. Sorry. I take this another one example. See this is one beam. This is one beam. So okay, two beams are acting. Two beams are acting. This beam dimension is a 5 meter. This beam is a 6 meter. I provided the column for this area. So I simply go for depth of the axis. Depth of the axis, I orientation into longer beam side. This is a correct or wrong? This is a totally wrong. The depth of the axis orientation into shorter span. So it's totally wrong. You changed the orientation of the column. This is the correct one. So depth is oriented into longer beam side. This is the main one. This is any orientation, your column depth will be orientation into longer span side. Okay, that is a main point. The first point is a corner will be provided for all the columns. Next is the intersection of the beam wall, compulsory you will be provided this column. The next one, longer span of the beam side will be oriented into column depth. This is an important one. This is the main orientation for your column, this point. Next one, avoid the large center to center distance between the column. Avoid the large center to center distance. Why? Why avoid the large center to center distance? Third point, the main point, avoid large center to center distance. Okay, why avoid the large center to center distance? You put this one column, this is another one column. You go for 10 meter, the bending and deflection will be high. So the deflection will be high. Your column will be go for higher spacing. The deflection and bending will be high. So you reduce your deflection and bending, you reduce your column sizes. Okay, that is the main point. Avoid the large center to center between the column. You avoid the large center to center. So automatically reduce your deflection and bending in your beam. That is the main point. Okay. Third point is avoid the large center to center distance for your column. This is a column 1. This is a column 2. Automatically you go for this column 1 and column 2 is a 10 meter, means automatically deflection will be high and the bending will be high. So I reduce my spacing, then automatically it will be reduced. The 3 points are main points to orientation of your column. The compulsory the column will be provided, then beam intersection place will be, and then orientation. The orientation longer span side, the column depth will be oriented. The next one is avoid the large center to center distance. Provided the large center to center distance for your column. Next one, column on property lines. Okay, later I will discuss column on property line. You are fixing on your column for your building the main 4 points. First, compulsory you provided the corner of your columns in building. Compulsory you provide the beam intersection areas and avoid the large center to center distance. Then orientation for your column depth in longer span side. This is the main point to orientation for your columns. Okay, this is the main point to orientation of your column. The next one, the column design. The column design is the first point. There's so many points of that load. Okay, first point is a load. Step 1, how to calculate at the load for your columns. Okay, I taken the first point, then I go for how to take the short column and long column, uniaxial, biaxial, axial. There's so many types of columns are there. Okay, I tell about what is meant by biaxial, uniaxial, and axial also. That is the main important one. The first step is a load. How to calculate at the column load? First of all, this is our beam load. Okay, for assumption as a beam, this is the 12-meter beam. The total load, slab load and other beam self height, all load will be acting on this. Totally this beam load is a assumption as a 10 kilonewton per meters. Okay, 10 kilonewton. I take this my self height of me all the loads. Okay, totally 10 kilonewton. How to transfer your column load? WL by 2. W by 2. Okay, simply you calculated your 10. Total load 10, half of the load, WL by 2. Okay, totally 10 divided by 2 means automatically the 5 kilonewton will be acting on this side. Okay, this is the main column. How to transfer the column in our rectangular only? The rectangular load will be acting on this one way slab. That is the formula. WL by 2, it automatically the load will be transferred. But you go for sometimes the two-way slab is the right. Two-way slab. This is our one-way slab. How to transfer the beam to column? Simply you provide the WL by 2, it's automatically load transfer to column. But you go for two-way slab, this is our two-way slab, right? This is our two-way slab. This is a 1 2. I take this 1 2 beam. So okay, I take this 1 2 beam 1 2, but it's acting on the triangle load, not a rectangular. But I take this one way slab, I take this one way slab, but the one way slab it's acting on this rectangular. This is, it's acting on this rectangular, but the triangle, this two way slab, it's acting on this triangle. How to transfer the beam to column for triangle load? Using WL by 3. Okay, you provided the WL by 3, it's automatically the load will be transferred. Using for WL by 3, it's refer from one cell book. Okay, triangle load it's using for WL by 3, but one way slab using for rectangular used for WL by 2. The total load divided by half of the portion will be acting on this one way slab, but the two way slab is provided for WL by 3. Okay, now it's clear. It's taken the totally on this load, total load acting on this beams. Okay, total load acting half of the portion is transferred to column. Totally my column load is a 20 kilonewtons. It is 20 kilonewton. Then how next procedure? How to design the column? What are the considered will be design your columns? The first one is a load. Okay, the first condition is a load. Second one is a moment. Okay, second one is a moment. This is the main thing. Okay, first one is a load. The load is transferred from beam. The already discussed about the load is directly, this is our beam. The half of the portion is transferred to column load, that is called RA. That is a load transfer to column. Second one is a moment. That is the main one, important one, the moment. So, okay. The types of columns. There are three types of columns are differentiated. Okay, three types of columns. Three type of columns will be differentiated. One is a axial column, another one is a uniaxial axial column, another one is a biaxial, and another one is a uniaxial. Okay, next one is a uniaxial column, next one is a biaxial columns. Okay, the next one is a biaxially column. That is a main important one to design your columns. Okay, biaxially loaded column. These three columns are main important to design in your column. This is step one. To understand this step one, first step is the type of column. How to take this, how to assume that your column is a biaxial or uniaxial and axial. The first of all, I tell about axial columns. Okay, I tell about axial column. The axial columns only taken for axial load. Okay, the axial columns is only taken for axial load, but minimum moment will be taken. Okay, minimum moment will be taken, minimum moment will be taken, but only axial load will be taken. Okay, axial column only axial load will be taken, otherwise the minimum moment will be taken. You provide the minimum moment for 8 kilonewton per meter. You provided the minimum moment for your axial columns. Okay, how to identify your axial column? The both directions, x direction and y direction. This is our cross section of the beam. This is the method. This is center portion. You simply, this is the x direction, this is our y direction. So load acting on this area, this is the load acting on this area. So no moment will be comes this side also beam in axial column, this side also axial. So the moment will be transference. Only the axial load will be travel on this column. This is the main axial. I simply draw this one real structure. Okay, simply draw this. This is our column, assumption as a column. This side also on beam is there. This is on beam, this is on beam, this is on beam. Okay, the four beams are available. This four beams are equal spacing. Okay, the four beams are equal spacing. That is called axial column. This side, two side, and this side also axial column. This is a four are uniform spacing. Okay, that is called axial column. Another one point, how to identify your axial column. The four sides are uniform length. Okay, the four sides of your beam, four side of your beam is a uniform length. Four side of your beam is a uniform length is called axial column. This is also 5 meter, this is also 5 meter, this is also 5 meter. This is called four side is a beam is a uniform, that is called axial column. Sometimes is named as a center columns. Okay, sometimes is named as a center column for your building. That is the main one. How to identify your axial? The four side of your beam is a uniform length is called axial column. Another one, center column. Another name is a center column or internal column. Any one name. Center column or internal column is another name. This is a main one. Okay. Main one to identify in your building. First of all, you identify your column, then go for your design short column, long column, or any one. Now let's understand how to identify the axial column. First of all, the four beams are acting on your axial column. The four beams are uniform length. That is called axial column. The four beams are uniform length. Then you go for internal column. Another name is called internal column. That is called axial loaded column. In this picture series, automatically this is a B1, B2, B3, B4. Four beams are there. Why the zero moment will be comes? Only minimum moment will be comes. That beam, the moment transfer to this beam. This beam moment transfer to this beam. So automatically the moment will be transferred to opposite beam. The no moment will be transferred to column. That is called moment distribution method. So axial load only taken into axial column only taken into axial load and minimum moment, that is called axial column. Then next one, that is understand this concept. The axial column means four side are uniform length of your beam. The beam will be transferred to this side of your moment. This side will be transferred. So that is the axial column. The next column, second column. Next one is a uniaxial loaded column. Uniaxially loaded columns. Okay. Next one is a uniaxial. Second column is a uniaxial loaded column. The uniaxial loaded columns are opposite two sides are uniform, other two sides are unequal. That is the main important. Uniaxial column, loaded columns are opposite two sides are equal. One is a x direction and another one is a y direction is there. Mx, My. Okay, two moments are using in our columns. This moment comes under only one moment, x direction or y directions. Okay, I tell about the first point. How to identify your axially loaded column means the opposite two sides are equal. Opposite two side equals. Okay, first condition. Other two sides, another two sides. Okay, another two sides unequals. Okay, another two sides unequal. That is the main important for uniaxial loaded columns. Okay, uniaxial loaded column. How to identify your beam? I draw this column. This is my column. Same like that. This is the one is a x and y. Okay, this is x direction and y direction. I draw this beam. This is the one beam acting on this column. In this type, this beam in this side will be acting, and this side four beams will be acting on this columns. Okay, four beam. Understand this, the opposite two beams are equal. This is a 5 meter, this is a 5 meter, and then this two beams, this is a 4 meter, this is a 3 meter. Okay, these are unequal beams. This is a unequal two sides. This is a equal two sides means easily transfer to moment in this direction, but is unequal, there's some moment transfer to columns. Okay, that is called uniaxially loaded column. Okay, your another name is a side columns. Okay, the another name is a side column. That opposite two sides are equal, the 5 meter and the 5 meter. Then other two sides are unequal. Now it's clear how to identify your uniaxial column in your building. One side x direction will be equal, y direction will be unequal. That is called uniaxial. Axial means x and y direction are same, so axial. These are two moments are there. This is the x direction will be equal means this moment will be, this is a y direction are equal beams, so y direction have a no moment, so it's come from x direction only, opposite direction, opposite different lengths, so it will be some moment transfer to columns. Mx or my, any one moment will be transferred to columns. Okay, that is the uniaxial loaded column. Okay, understand, only any axis, x axis or y axis. Okay, this is the moment, x axis or y axis, any only one moment, that is called uniaxial loaded column. The next column is a biaxial loaded column. The third column is a biaxially loaded column. Biaxially loaded column. How to identify your biaxially loaded column? Same procedure. The biaxial columns are adjacent two sides are equals. Okay, adjacent two sides are equal. That is called biaxial columns. The first point is a adjacent two sides. Adjacent two sides are equal. Okay, first point is a adjacent two sides are equal. Adjacent two sides means I simply draw this columns. Okay, I simply draw this column. Adjacent two sides are unequal, sorry, unequal, not equal, unequal. Adjacent two sides are unequal. I draw this beam, this is a one beam for this area, the four beams are acting on this column also, four beam, but the four beams are different sizes. This is a 4 meter, 3 meter, this is a 4 meter, sorry, 5 meter, 4 meter. The four beams are unequals. Okay, the four beams are adjacent two sides. Maximum the corner column, the corner column is a biaxial column. This is our building corner. Okay, this is our building corner. I provided this column. This is a 5 meter beam, this is a 4 meter beam. This is adjacent side, this is also unequal, this is also unequal, so that is called adjacent. Another name is a corner columns. Okay, that is another name is a corner column. This column will be both axis on this moment also. It will be both axis on this moment. Okay, both axis will be comes under the moment on this biaxial loaded column for x and y axis also. It's mentioned as a mx and a my. Now it's clear. Uniaxial, it comes from any one axis, x axis or y axis, but biaxial loaded columns is a corner columns. Okay, biaxial, the maximum using on this corner side of the building. Is that two of adjacent sides are unequals. Two adjacent sides are unequal, so two moments will be transferred to columns. That is, the two adjacent sides are unequal. That is called second point is a corner column. The both two moments will be in this x direction and y direction. Now it's clear. This is the main point to create this axial loaded column, unaxial, uniaxial, biaxial. You simply draw this one plan or residential building. The axial column will becomes, uniaxial column will becomes biaxial. How to differentiate this axial, uniaxial, biaxial? Follow this. This is a method to follow your uniaxial, biaxial, and axial columns. Axial will be no moment, only minimum moment. Uniaxial will be one direction only, any one direction, x direction or y axis or x axis, any one axis will be moment will becomes. Biaxial is a corner column. The two axis will be comes on this moment, x axis or y axis. Okay, this is the main important one for your classification of your columns. Okay, the first step is over. The first step, you identify your columns, axial, biaxial, and then finally uniaxials. Okay, 3 columns, the finally classified. This is the main things we'll briefly discuss about like that 3 of it. Next one, the next step is a design. First of all, I identify this, then go for design. Design means you finally calculated your column, short column or long column, long column or short column or slender columns. Okay, slender column. How to identify your column is a short column or long column or slender column, anyone, it's a no problems. Okay, short column or long column, it will be follow. How to identify your column is a short column or long column? The simple procedure. First of all, you identify your length of your column, then calculate the unsupported length, and then go for effective length. Okay. I tell about how to calculate the short column or long column for your building. First of all, I calculated the effective length and slenderness. Okay. Effective length, then slenderness. Okay. First of all, I take this floor to floor height. As this my I take this floor to floor height. First of all, floor to floor height. Okay. This is our floor to floor height. I take this approximately my story height. Floor to floor height means okay, bottom floor to top floor, including beam also. Okay. Including beam also, I take this floor to floor height. I simply take this my building floor to floor height is a 3000 mm. I simply draw this one rectangular. See this is one rectangular. This is our floor. Okay, this is our floor. This is our beam also. This is the next floor. This height is a 3 meter height is a floor, including beam and slab also. Including beam and slab, it's automatically it's calculated the first of all floor to floor height of your building is a 3 meter or 3000 mm. Okay, this is a 3 meter or 3000 mm. Then minus your shallow slowest beam. Okay, minus your depth of the beam. Next step is a minus your depth of the beam. Depth of the beams. Okay, depth of the shallowest beam. I simply go for my beam depth. Assumption I take this. My beam depth is a assumption I take this 300 mm. For my beam depth is automatically I take this 300 mm. First of all, you go to write this 300 mm. My beam depth is a 300 mm. This is a 3000 mm. Okay, this is our 3000 mm. Then how to calculate the unsupported length? You will be go for unsupported length. Then you convert it into short column or long columns. Okay. First of all, then you calculated the next step. First step is a floor to floor height. Then next one is a depth of the beam. You know that is a depth of the beam is 300. Next one is a unsupported length. Unsupported length is a L. Okay, this is a unsupported length. How to calculate the unsupported length? Unsupported length is a total. You minus this automatically. 3000 minus total depth of the beam is a 2700. Okay, 2700 automatically minus this unsupported length. Then into your conditions based on your conditions. See this automatically I show that in this detailed one. See this is our calculation. This is a effective length of the column and type of the columns. Okay, effective length and type of the column. This is our total building floor to floor. This is our floor to floor. Automatically our floor to floor is a top floor including slab. This is our floor to floor height is a 3000 mm is a 3 meters. Okay, 3000 mm it's a 3 meter. Then our beam depth is a 300 mm. Then you calculated the effective length is a formula. Then you go for your effective length. L is automatically minus this 3000. Total length is a 3000. Okay, total length is a 3000 minus 300. I take this length, then into in your conditions. For your condition is based on your conditions, it's given in IS456, but it takes in some values. For this IS456, you see in this graph, end conditions, fixed condition, one end is fixed, other end is free, two ended are skins, that type of conditions are there. That type of conditions, I will show one condition. This is our condition. I take this for top story, I taken into L, otherwise intermediate story 0.8 into L. This is our unsupported length. I taken into, I assumption as a top story. Okay, I assumption as a top story. I simply go for assumption as a top story. This is my top story. You calculated every story also. Every story you calculated the length unsupported value. I simply calculated my unsupported 2700 into L. It's automatically is taken into 2700 mm. Okay. You simply calculated this unsupported length. You go for intermediate story 0.8 L. Then go for column with bottom story plinth area. Then other formulas are there. Okay. Next step is how to find your column short or long columns. Okay. Next, how to find the column short column or long column. Then simple procedure. There is a formula is a formula. The column effective length. Okay, this is the effective length. Effective length divided by width of your columns. Okay, f2 length divided by width of your column. It's calculated the short column or long column. You go for ground floor or any floor, the short column and long column are so many columns, it will be comes. Okay, you simply take this one residential building, uniaxial, biaxial, axial, the so many columns are there. And you go for your design, short column, long column, and so many. As a short column it's under crushing, long column it's go for buckling. You see this IS456, I show that how to take this effective length, all of us. This is our table. Yeah, this is the effective length for your column. Effective length is compression number. Is the column is a compression number as at anyone. I take this effective length. The first condition is a fixed conditions. Okay. I take this 0.5 L or theoretical value. First, this is a buckling one. This is a buckling. Okay, this is our buckling or bending. You same like you will be rotated into beam. Same values it will be comes. Okay, based on your beam condition also. Based on your fixed conditions, or one end is fixed, another end is free cantilever, that type of based on your beam condition also. This compression value, you take this theoretical also. Okay, the theoretical value, and all of us take this table effective length of compression IS456 page number 94. I take this 1L or 1L, your two end are fixed, two end are hinged based on your bending. This is a bending column also buckling. This is a buckling condition, resistive buckling based on this condition. One end is fixed, other end is freeze. Okay, I simply take this my column length is a L condition. This is our condition. This is fixed. I simply, this is our buckling for your column. Long column it will be buckling, and short column it will be crushing. Then how to calculate the short column or long column? Our F2 length is a 1700 divided by our column depth. Our column depth width, column width based on my wall thickness. I simply provided 230. I simply provided 230. 2700 divided by 230. This is 11.7. Okay, this is 11.7. I taken into 12. It's a 12. It's a short long columns. Okay, always 12. It's go for short column. So, okay, it's a go for 11.7. So is design as a short columns. Okay, design as is 11.7. I design as a short column. Short column is a simple procedure, but you go for long column, there's so many procedures to design in your columns. Okay, so you simply go for divided by columns is automatically this divided by 2 based on your column width. Is it 200? Is it 13.2? Is a long column. Less than 12 is a short column. Greater than 12 slender long column. It's our column 2700 divided by 230. Our width is a 11.7. Is a short columns. Okay, short column is a design procedure is a simple. You refer that SP16 code book. All the formulas are available. Easily design your all the things. Okay, this is the basic main things for your short column or long column. First step is a you identify your axial, biaxial, uniaxial, then go for design, and then you identify your column height, beam depth, which floor you will be column will be there. Then separate your table also. The first floor, I have a uniaxial column is a 5 numbers, biaxial is a 6 numbers. Then identify your short column is a 5 numbers and a long column. Then you go for your design in Excel sheet or anyone's. Okay, now it's clear how to identify your short column or long column, biaxial, uniaxial. This is the main one for your column designs. Okay, this is a column design, the same procedure. Next one is the eccentricity. The eccentricity is the minimum eccentricity follows on this 20 mm based on your column condition. The minimum eccentricity follow on this 20 mm. Is the formula is automatically provided the conditions. The next one allowable slenderness and the initial moment for your based column and based column. And then so many types are there. You will be follow this design initial moment. You calculate the braced column and unbraced columns. Okay, this is the main concept. Then you go for next one. How to reduce your column load. Okay, simple example. These are conditions. Okay, I tell about another one. How to reduce your column load. Only compression. How to reduce your column load. For example, see this. This is our column. This is our floor. This is different beams, different floors. Okay, this is our different floors. See this. Automatically, this is our different floors. How to reduce your column load? First of all, I take this some column loads. This is the 230 kilonewton for this column. This is the ground floor. This is the first floor G plus 1. This is the G plus 2. This is the G plus 3. Okay. This is G plus 3. G plus 3 is the 230 kilonewton. The load will be acting. Then next one G plus 2. The G plus 2 is a 400 kilonewton. It will be acting. Next is G plus 1. The G plus 1 will be 800 kilonewton. The finally the ground will be acting 1200 kilonewtons. Okay. Based, this is the load acting on your top floor. Next G plus 2, G plus 1. This load will be acting. How to reduce your loads? This is our compression load, compression number load. How to reduce this load? Say 800. How to reduce this load? As per IS 875 part 2. Okay, you will be reduce your compression member load also using for live load reduction factor. Live load reduction factor, you will be reduce your compression number load only as per IS 456, sorry, IS 875 part 2. Go for live load reduction factor. See this, I show this table. The first of all, you comes under the top to bottom. Okay, not a ground to top, top to bottom. This is our first floor. This is at the top terrace is the first floor. Then mention this 3 4 5, this top to bottom opposite side. Okay, the top floor, the terrace floor is the first floor. Then otherwise the your fifth floor is a second floor, fourth floor is a third floor. Then for opposite direction is a mention this. Okay, then how many percentage will be reduced on your first floor? This floor is a 0. Okay, then second floor you reduce the 10 percentage. Then third floor I show the table. This is our reduction table for your compression load. For your only you reduce the compression load only, not a beam load, slab load. It's reduced only for compression load. See, this is as per IS 875 part 2. Its table will be given on this IS 875 part 2. The first floor is a 0 on this top floor. This is the top floor. So no reduction. You take this 230. Then next one. The next floor, second floor 10 percentage. Third floor is a 20 percentage. Fourth floor is a 30 percentage. 5 to 10 floors, it go for 40 percentage. Over 10 floors, you will be reducing the 50 percentage of the live loads. Okay, reduce the column load compression number. This is the main advantage. You reduce the sizes and others also. Okay, the first floor is a 0, then second floor is a 10 percentage, and the more than 3 is a 20, more than 4 is a 30, 5 to 10 is a 40, and over 10 is a 50. This table also given in IS 875 part to see this automatically. This table I show that this is the first, this is the top floor, this is the roof level, this is a roof level. It's acting on this 30 kilonewtons. Okay, it's acting on this 30 kilonewton, but it's take directly on this 30. The next floor, second floor, the total load is the 30 plus 40. 30 plus 40 is the 70. I minus my 10 percentage, total 63. But our load is a 70, but I actually taken for 63. I minus the 10 percentage of the load. Okay, then next to go for next floor, third floor, total 50 plus 40, 90, 120, 120, is 120. I totally minus 20 percentage. My total load I taken for 96 as per 875 part 2. Then more than 5 floors, see this 5 floors, you go for 40 percentage load will be reduction. More than 5 floors, 5, 6, 7, it will be reduction only 50 percentage of the loads. Is automatically it will be 50 percentage of the loads is automatically. This is the main one. You reduce the column number only, not a beam and slab. It reduce the column number only. It's a compression number. Automatically you will be reduce the column number. The footing and otherwise it will be comes under smalls. Okay, this is the main advantage for reduce your column size and AST values for your areas. Okay, this is the main one, imposed load for your columns. Okay, next one. Next one, this is a method to already discuss about what is meant by axial column, axial, uniaxial, and a corner column also. Next one, how to design in your column means first one, load on your column. Earlier it will be discussed. What are the loads, how to load acting on this beams and others. The next one is a moment. We'll discuss about the axial column moment, biaxial column moment, uniaxial column. Then discuss about the effective length also. Discuss about the effective length. Then you calculate the short column. Then you go for direct design. You follow the SP16. You will be design on direct. Okay. Then type of column, the same one, short column or long column. It's also discussed. Then finally grouping of column. So what is meant by grouping of column? You taken the 10 to 15 columns in your buildings. Okay, what is my grouping of column means? You taken the 5 to 10 columns in your buildings. Okay, grouping, uh 5 5 to 10 columns. Okay, the first one, 1, 2, 3, 4, 4 columns are there. 4 columns are the same size, 230 by 450. Next 5, 6, 7. These are all 230 by 550. Next one, 8, 9, 10. These are all 230 by 600. Okay. See, this is the grouping. You group this 1, 2, 3, 4. 4 column are same size. Same size, I simply provided this group 1. Okay, simply provided this group 1. 5, 6, 7. It's provided the group 2. Is the size is the same. It's the 8, 9, 10. The 8, 9, 10 is the group 3. The 8, 9, 10 is a group 3. It's for same sizes. 230 by 600. This is the main grouping for your columns. Then finally you go for design in your column section. We already discussed about the load, moment, effective length, type of the columns, grouping, and all the things. Okay, I discussed about the all the things. Final another one. Next one is a reinforcement detailing for your columns. Another basic design for your AST as the same procedure will be follow on this SP16. All the procedure will be there. You go for short column as a design is the long column. You simply take this value, then you will be take the design values. Finally, AST values and all the values. Okay. Then next is a reinforcement detailing. The reinforcement detailing for your column. Okay, reinforcement detailing. The reinforcement detailing, the longitudinal reinforcement. See, this is our longitudinal reinforcement. To provided this column, this is our column. Longitudinal reinforcement is a no problem. It's a beam junction. Okay, this is our beam junction. This is also beam reinforcement. This is also column reinforcement. See, this longitudinal bars you provided based on your conditions. Two sides are equal or four sides is a no problem. I provided the two sides of four number 16 dia in ties. This is a beam is a stirrups, the column is a ties. I provided the column ties. See this area I will be provided the beam column joint. The beam column joint I will be provided the tie spacing is a smaller. This size spacing I provided the 150 mm. Another spacing I provided the 200 mm for your tie spacing. Why the beam column will be joined for this tie spacing? I simply draw this end. This is our fixed end. See, this is our fixed end. Okay, this is also fixed end. I simply draw this one shear force diagrams. Okay, see this. This is our shear force diagram. Shear force will be acting on this beam and column portion also. This portion or some of the column portion also the shear will be acting. So I reduce the column tie space on this beam column joint. So the some of the shear will be act on this column also. So I provided this sizes for your columns. Now it's clear why the ties will be spacing will be less in beam column joint. The shear will become so it will be reduced. Next one is a ties. Sorry, reinforcement is a cross section. How to provide the reinforcement? Same like this. The bottom bar. I provided the phone number. I simply provided this four bars for this column. Stirrups are there. So many stirrups, open stirrups, two leg stirrups. All the stirrups are there. I provided this is my four bars, four numbers of 16 bars. Okay. Then another one column. I have a 16 bars. 16 rebars. Okay, how to provide the 16 rebars for my column? There is a 4 easy. Then you provide the 6 also easy. 1, 2, 3, 4, 5, 6. Okay, you will be provided the outer stirrups. Then this corner will be provided some diamond stirrups. Okay, diamond stirrups for your 6, 8 numbers. It will be easy. You will be provided the diamond stirrups and other stirrups also. Then how to provide the maximum 12 numbers of bars will becomes on this column, 16 numbers of bars. How to provide your reinforcement arrangement? Simply you go for SP34 code books. Okay, you simply refer your SP34 code book. Then you take this reinforcement details. See, this is our rain SP34 code book page number. The four bars are minimum, three bars or six bars are easy. Other than 16 bars or 20 bars, it will come. Sometimes it's a this type of columns will be using for this apartment works. This meter is a 1000 mm. 1000 mm, 1 meter depth. 1 meter depth, it's have a more than 15 to 16 columns are there. So it provided this type of ties for your columns. Okay, this is the ties for your columns. Okay, now it's understand how to provide the reinforcement detailing for your columns also. Okay, this is a reinforcement column. This is another column. This is a real life picture for your reinforcement columns for your buildings. The next one, how to check your values. How to check your values in this column design. How to check your column values. Okay, how to check your column values? Okay, as per is 456. Okay, as per 456, the minimum percentage, the maximum percentage are ast reinforcement. The reinforcement steel percentage is there. Reinforcement steel percentage, the minimum percentage for your column is a 0.85 percentage. Okay, the minimum percentage for your column is a 0.85. The maximum percentage of the steel percentage is 6 percentage, 6 percentage maximum for pier construction, pier bridge construction. For normal building, residential building, commercial building, it's go for 4 percentage. ec- economical, it's go for 2%. You check this stat pro, it's automatically it will be comes. This is the steel percentage. Minimum is go for 0.8 percentage. The maximum 6, the building, residential building, that type of, you go for 4 percentage. Then the economical, you go for 2 percentage for your steels. Okay, and what is the minimum dia for your column? Minimum dia for column is a 12 dias. Okay, minimum dia for your column is a 12 then next one is a minimum bars, number of bars for your column, for your columns, number of bars minimum. For rectangular, 4 numbers. Okay, rectangular 4 numbers, and circular 6 numbers. Okay, circular 6 numbers, rectangular 4 numbers, circular 6 numbers. The minimum spacing of the bar, minimum spacing of the bars, the minimum spacing of the bars equal to 75 mm. Okay, minimum spacing of the bar is a 75 mm. It's all the values are given in IS 456 also. It's all the percentage value, all the values is in IS 456. I show that all the values for column, what is the minimum percentage and the maximum percentage, the column design formulas, and all the values. We show that how to take this minimum value, maximum percentage, and all the column values. Once again, this is beam and reinforcement and the column values. Sir, I show that how to show that your column values, minimum bars and maximum bars for your columns. This is side face. Yesterday we'll discuss about the minimum percentage of the tensile reinforcement for your beam is a page number 47. You will be refer that minimum percentage of the tensile reinforcement is given. The side face reinforcement also 750 mm. So all the values are in this code book also. This is a mini maximum spacing for shear reinforcement for your beam is given in this table, and compression reinforcement of minimum percentage of the beams will be given. Then this is shear formula. So all the formulas will be, it's given in this code book also. Page number 47 and 40 is the beam, all the things will be given. Next, column. See, this is a column. You simply study that longitudinal reinforcement. The first point it will be gives in this, the minimum percentage of steel percentage reinforcement shall not less than minimum reinforcement not less than 0.8 percentage. Then you go for maximum percentage, it will be give the 6 percentage. It will be give the code book also. Then longer cross section, the minimum number of longitudinal bars it will be provided, 4 number of rectangulars, 6 number of circulars, and a bar shall not less than 12 mm. Then reinforcement, helical reinforcement, 6 bars will be provided. Then spacing of longitudinal bars along with the shall not be exceed 300 mm. So all the details will be given. The pitch distance and lateral distances will be given. The pitch distance, at least the compression number 6 times smaller dia longitudinal and 300 mm. Then diameter is a diameter, it will be given in case of the polygonal links is less than 1/4 of the diameter of the longest longitudinal bar. The helical reinforcement, the arrangement of the reinforcement. See, this longitudinal bars not spaced more than 75 mm. Once you provided the reinforcement detail, you will be refer that the longitudinal transfer for not more than 75 mm. All the details it should be given in this IS 456. This is the distance 75 mm. This is the distance for your 75 mm for this column. Also refer your SP34 code books. It's taken all the values for your column details and others. So all the formulas will be given. You go for this beam minimum and maximum. It's all the shear and it's also given in this area explosive condition. This is a nominal cover for your buildings. Okay. This is the basic things to design in your beams, columns and slabs. All the maximum values are taken from this IS 456 also. You calculated the development length for your column. This is the length for your ball bars in this beam also. You calculated the beam for development length. You refer the page number 42. You will go for this sigma dB values for your areas. Okay. First of all, you fully thorough it on IS 456, then go for your design for your any design. Framed structure like a beam, column, slab or any ones. Okay. So okay, this is the basic concept for your column design. These are the another columns for your buildings. Yesterday we'll discuss about the beams and other activities also. Okay, these are the some beams images. This is the one is the beam is a secondary beam. This is a secondary beam. The secondary beam is acting on this point load on this main beams. Okay, this is the secondary beam. This is the hidden beams. The hidden beams are provided in the slab portion. The slab is a long area. The hidden beams are resist some loads and it reduces the thickness for your slabs also. This is the hidden beams. The hidden beams is provided for this slab, reduce the slab thickness and deflection also. It provided the hidden beams. This is the next one is the inverted beam. The next one is the inverted beam. The inverted beam is a maximum same like a WR singly reinforcement, but is provided in the top of the slab. See, this is our slab, but the inverted beam is provided in the top of the slab. This is the bottom of the slab. The beam will be provided, but this slab it will be provided on this top. So that is called inverted beam. It's maximum used for this architecture purpose also. This is used for architecture purpose in this inverted beams. Is automatically is provided the inverted beams for your architecture purposes. This is our yesterday we'll detailedly discuss about this is our secondary beams and all the beams. This is tensile reinforcement and the other reinforcement also. This is our deep beam. This is our deep beam, the mainly used for your bridge designs. Okay, this is our slab. This is a same like this. This is our yesterday will day one will be discussed. This is a diagram. This is a one-way slab. The one-way slab will be longer side will be direction. The two-way slab, it's all the side will be transverse. Okay. Now it's clear how to take the values for your column design and all the values is the main one. Then other design procedure, it's go for easy one. Simply take any book or code book, you simply refer that, then go for your designs. Okay. Okay, fine. Thank you all. Now it's I complete this section now itself. I put the link in chat box for attendance form. Please fill it. Tomorrow we'll discuss on footing, then go for design in your building in this stat pro. It take the values. Okay, this is the today we'll discuss about what are the needs to design in your column: axial, biaxial, uniaxial. Then what are the needs to short column, you calculated the effective length and all the things as per IS 456. Okay, now it's clear. Our day one will be discussed about slabs, day two will be beams, and today will be discussed on columns. Tomorrow will be discussed on slab and others. Okay. Okay, fine. Okay, please fill this feedback form by attendance form. Tomorrow will be same time we'll discuss on footing. Then you go for software links.